Welcome to our deep dive into the complex and controversial world of geoengineering, a potential but contentious solution to the urgent crisis of climate change. In this video, we'll explore what geoengineering is, the various techniques involved, including solar radiation management and carbon dioxide removal, and the potential benefits these methods could offer. However, we won't shy away from discussing the high costs, technological challenges, and ethical dilemmas associated with these strategies. Join us as we examine whether geoengineering is a risky necessity in our fight against climate change. 1. What is geoengineering? Geoengineering is a term that refers to deliberate, large-scale interventions in Earth's natural systems with the aim of counteracting climate change. These interventions are typically divided into two main categories: solar radiation management, SRM, and carbon dioxide removal, CDR. SRM focuses on reflecting sunlight away from Earth to reduce global warming, while CDR aims at removing carbon dioxide from the atmosphere to tackle the root cause of climate change. These strategies are often seen as controversial due to their potential unknown impacts on the environment and society. However, as climate change continues to pose a significant threat, geoengineering is increasingly being considered as a possible solution to mitigate its effects. 2. Solar radiation management, SRM, technique. Solar radiation management, SRM, involves various techniques designed to reflect a portion of the sun's rays back into space, thereby reducing the amount of heat that reaches the Earth's surface. One method includes injecting aerosols, such as sulfur dioxide, into the stratosphere to form reflective particles. Another approach is cloud brightening, which involves spraying fine seawater to make clouds more reflective. While these methods could potentially reduce global temperatures quickly, SRM does not address the underlying issue of greenhouse gas concentrations. This means that while it might offer a temporary fix, the root causes of climate change would remain unaddressed, making it an incomplete solution. 3. Carbon dioxide removal, CDR, method. Carbon dioxide removal, CDR, targets the removal of carbon dioxide from the atmosphere, addressing climate change at its core. Techniques for CDR include direct air capture, where machines filter carbon dioxide from the air, and ocean fertilization, which involves adding nutrients to the ocean to boost the growth of carbon-absorbing algae. Afforestation, or planting trees, is another method, as trees naturally absorb carbon dioxide. These methods aim to reduce the existing levels of carbon dioxide, directly tackling the primary driver of climate change. However, implementing these techniques on a large scale poses significant challenges, including high costs and technological limitations. 4. Potential benefits of geoengineering. If geoengineering techniques are successfully implemented, they could offer significant benefits in the fight against climate change. For instance, they could rapidly decrease global temperatures, providing much-needed time for countries to implement long-term emission reduction strategies. This could help mitigate severe climate impacts, such as extreme weather events, sea level rise, and biodiversity loss, which are becoming more frequent and severe. The potential to stabilize the climate quickly makes geoengineering an attractive option for some scientists and policymakers. However, the benefits must be weighed against the risks and uncertainties associated with these interventions. 5. High costs and technological barriers. One of the main challenges of geoengineering is the high costs and technological barriers associated with its implementation. Developing and deploying these large-scale interventions require significant financial investments and technological advancements that are still under development. For instance, building machines for direct air capture or developing the infrastructure for stratospheric aerosol injection demands substantial resources and expertise. The financial burden of such projects can be prohibitive, especially for developing countries, raising questions about the feasibility and equity of geoengineering as a global solution. 6. Risk of unintended consequences. Geoengineering carries the risk of unintended consequences, which could have far-reaching and potentially harmful effects on the environment and society. For example, altering weather patterns could disrupt precipitation and agricultural cycles, leading to food shortages and economic instability. Additionally, there is a risk of damaging ecosystems, as changes in temperature and sunlight can affect biodiversity and habitat health. Furthermore, there may be geopolitical tensions over who controls the technology and benefits from its deployment. These risks highlight the need for careful consideration and rigorous testing before implementing geoengineering techniques on a large scale. 7. Moral hazard of geoengineering. Critics of geoengineering often cite the moral hazard it poses, suggesting that reliance on such technologies might reduce the urgency to cut greenhouse gas emissions. This over-reliance on a potentially risky, quick fix could undermine efforts to transition to sustainable energy sources and reduce carbon footprints. By providing a sense of security, geoengineering might delay critical actions needed to address the root causes of climate change. The fear is that geoengineering could become a distraction from the necessary work of reducing emissions and achieving sustainable development goals. 8. Governance and ethical dilemmas. The governance of geoengineering presents significant ethical dilemmas, as there is currently no global regulatory framework in place to manage its deployment. This raises questions about who should have the authority to make decisions regarding its use and how to ensure that its potential risks and benefits are distributed fairly. Ethical concerns also revolve around the potential for unintended consequences and the lack of public consent for such interventions. Establishing a comprehensive governance framework is crucial to ensure that geoengineering is used responsibly and ethically, with input from a diverse range of stakeholders.